Okay, so before we start talking about nomenclature, it's important for us to understand the formation of ionic compounds from their component ions. So a cation and an anion will come together to form ionic bonds, yielding a neutral ionic compound, so a compound without a net charge. Now, in many of the cases of our common ions, we can predict the charges of the ions that will form based on the position of the particular element in the periodic table. So, for example, if we look at our periodic table, and here is just a simplified version, we will see that in group 1, what we call our alkali metals, all of these metals will have a tendency to form +1 ions. That is, they will lose a single electron, becoming the lithium +1, or the sodium ion, or the potassium ion, rubidium. Group 2 ions tend to lose 2 electrons, forming +2 ions. So the common ones here are magnesium and calcium. In group 3A, we have the common metals that we see will form +3 ions. That is, they will lose 3 electrons, becoming the aluminum ion, which has a charge of +3. For our nonmetals, these tend to gain electrons, becoming anions. And so notably, we have our halogens here, which have a tendency to gain a single electron, becoming the -1 ions. And so we call these fluoride and chloride, bromide and iodide. Our group 6 are chalcogens, most importantly including oxygen and sulfur, tend to gain 2 electrons, having a -2 charge. Nitrogen and phosphorus gain 3 electrons with a -3 charge. So we have fluoride, oxide, and nitride. Okay, notice that the names of these ions are sort of tell us whether it's a cation or an anion. So notice that all of our cations, we name these ions just as we would the neutral element. So sodium becomes the sodium ion, and we just call it sodium, or magnesium, or aluminum. So the name of the ion does not change. Whereas our anions, fluorine gains an electron and becomes fluoride, or chloride, or oxide, or sulfide, or nitride, or phosphide. Okay, so that's something we want to understand. And when these ions then come together to form ionic compounds, they do so in such a way that the resulting ionic compound has no net charge. That is, the positive charges of the cations exactly balance the negative charges of the anions. So the net charge is 0. And a very simple example here, if I can get my pencil out, a very simple example would be the sodium ion, Na+, comes together with the chloride ion to form a very common salt, sodium chloride. So NaCl, one sodium ion with one chloride ion to yield the net neutral compound sodium chloride. If instead of sodium we had magnesium with a +2 charge, because the magnesium has a +2, that means we need 2 of the -1 chloride anions to come together to form magnesium chloride with a net neutral charge. And so this will always be the case when we form ionic compounds. The resulting ionic compound will have a net neutral charge. So here's a table of our common ions. So we have cations over here on the left. We have our common anions on the right, and again notice the anions always have the IDE ending, whereas the cations, we simply name the ion by the parent element. So we'll do just one or two quick examples again. So we see if we have something like aluminum, which has a +3 charge, right? So we'll have aluminum 3+. And if we then bring this together with something like, let's say, bromide, Br-, right? Since we have 3 positive charges on that aluminum ion and a 1- charge on the bromide ion, that means we have to bring together 3 bromides with that 1 aluminum. So we would write the formula as AlBr3.
If, on the other hand, we were forming an oxide with aluminum, so we've got 3 plus charge with aluminum, oh goodness, and a O oxygen with a 2 minus charge, so the oxide anion, we would need to bring them together in such a way that these charges will exactly balance. So in this case, a quick way to sort of see this is the magnitude of the charge on our ions will sort of become the subscript for our formula. So we're going to have to bring 2 aluminums together with 3 oxygens. So a total of 6 plus charge in those 2 aluminum ions and a total of 6 minus charge in those 3 oxide ions. So whenever we form ionic compounds, this is always going to be our rule, that the resulting ionic compound will have a net neutral charge.